All right, our next combinatorics lesson. So the idea today is that we're trying to learn how to count really large. Uh, we compare this to old things that we've done in probability, ideas like that, and typically our answers have always been, less than 1,000. Today we're going to be going far past that. So for my first example, I've got 5 people. They try and stand in a line, maybe to go to the movie theater or something. How many ways can they do this? Before I begin that, I'm going to look at an example from grade 8. So suppose there weren't 5, there were just 3 people. We could actually set up what we call a probability tree very easily for this. Show our 3 people in first position, figure out how many ways people can stand behind each one of them, and then our third position would just be the leftovers. If we count them, there's 6 ways to do this. So for 5 people, initially, you wouldn't think it's very much more at all. But if you set this up using what we call the blank approach, we're able to see right away that the number is large. In first position, there's 5 possible people to stand there. Once you've used up 1, there's only 4 more who can stand in second position, 3 in the third, and so on. There's 120 ways that you can line up 5 people. If you compare this to our grade 8 problem, you see it works out to the correct net number. For my second example, I want to talk about BC license plates and the way they were about 20 years ago. So 20 years ago, for most of our cars, they all had the same style license plate. It went letter, 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 number, number, number. We of course know that there's 26 letters in the alphabet, 10 different digits, 0 through 9. And for license plates, we were always allowed to repeat these. So you could see an example kind of like AAA999. If I was to put this together then using this blank approach, I would find out that there's 26 cubed times 10 cubed, which gives me 17.5 million license plates. Imagine trying to do that as a grade 8 tree. For my next example, we'll talk combination locks. So combination locks, you've got dial locks on your lockers. There's 60 different numbers, 0 through 59. And if you had a company try and do this properly, they would actually have every single possible combination, which would be 60 cubed, 216,000 possibilities. Manufacturing-wise, that's not very practical to do. So lock companies tend to come up with little shortcuts, such as the first number, they could say could be any number that you want. And the second number, to cut down the manufacturing process, they might say they have to be a multiple of 3. Well, there's 19 of those from 0 to 59. For your third number, you'd end up looking at something along the lines of, let's just use something different than the first. There's 59 of those numbers for a total of 67,000. A lot less than the first, but easier on the manufacturing. So one thing we need to note is the difference between what we call the blank approach and what might be a factorial number. So factorial numbers are often used like our lineup of people. When you start with a group, you begin with the first number and you count down all the way to 1. By definition, we're going to have a very special notation for this. As we can see on the screen, 5 factorial is 120. 36 factorial is 3.7 times 10 to the 41. I don't even know how to say that number. So because of this, we don't want to work with calculators other than using our proper notation. And you might recognize this exclamation point notation from my website. N factorial is n times 1 less than n times 2 less than n, just the way we count down, all the way down to times 3 times 2 times 1. Please note, n must be a positive number. It must be a natural number, no decimals. 1 factorial is defined as 1. 0 factorial is defined as 1. So that's leaving us then with, what are we going to do here? Are we going to always take a look at factorial? Are we always going to take a look at the blank approach? We need to be able to know the difference. Again, a factorial starts at a number and counts down, whereas a blank approach is usually used for examples like what I have right here. We've got Susie, 24 shirts, 7 pants, and 6 pairs of shoes. She takes one of each, puts them together for an outfit. How many ways can she do this? Is it a factorial? Well, no, because I'm not multiplying 24 by 23 by 22, etc. I'm just going to be saying, pick one of the 24 shirts, one of the 7 pants, and one of the 6 shoes, put them together, and we find there's 1,008 outfits. Well, this leaves us then with some homework to be done to make sure we're understanding this material. I look forward to seeing you on Wednesday for our next Zoom meeting, and I'll answer any questions that you have at that time. Enjoy working on this work.